Algebra 1, Module 1, Quantitative Reasoning, Lesson 1.1, Solving Equations. Please pause the video and work on these questions, please. Okay. After you check the video, in the answer, which you could see down here, it's upside down. And real quick, this one, we multiply by reciprocal to 4. And once you do that, 1/4 and 4 cancels, and 1/4 of 32 is 8. And here we're trying to balance the equation by doing so, but the ultimate objective is to isolate the variables, right? So we subtract 9 from both sides, which ends up with a 0 here, and 23 minus 9 yields 14. And for this one, to get rid of the 3, we multiply 3 to both sides, and that cross cancels. 16 times 3 is 48. And in this particular case, we're looking for the scale factor, and then we generally put the actual length in the denominator, right? So the actual room length is 144 inches right here in the denominator, and the scale drawing in the numerator. And then instead of just crossing off numbers like this, you ask yourself, what do they have in common? Well, if you can't see that right away, you could just break it down with the numbers that you see right away. So 144, is 12 times 12. And nice number that divides 18 is 6 and 3. And then if you look at the first fraction, 6 over 12 gives you half. 3 over 12 gives you 1/4, which is 1/8. So there are many ways to do this, but this is a kind of nice way to sort of leave the evidence of the work, and it sort of helps you go through calculation, and it allows you to go back and check your work. Okay. All right. And in this particular case, if you see that this 6 over 90 was 1/15 right away, that's great. We know that the original value goes in the denominator and the model goes in the numerator to find the scale factor. So the answer is 1/15. But the way you would do that perhaps is, 6 goes to 90 right away. You could do a long division, or at the same time, you could say, hey, wait a minute, 6 is 3 times 2. And then does 3 divide 90? And it does. Right, so it's 3 times 30. So 3 over 3 is 1. And 2 over 15 is a little easier. It's 1/15. And that's how you might do that, okay? All right, guys. Generally, I leave this to go over in class. I just want to go over a couple of questions. And I'll leave that for classroom discussion, okay? All right, guys. Here we go. So, you should be copying down the underlined forms. An equation, underlined words, I meant to say. An equation is a mathematical sentence that uses equal sign. It does the equal sign to show two expressions are equivalent. Expressions can be numbers, variables, constants, or combinations thereof. So that implies that the thing that you see is called an expression. On the left and the right, I call expressions, and that could be made of combination of numbers, variables, constants, right? Or just by itself, for example, 3. So let's try this solving equation in a guess and check and working backwards approach. Think of x as something. It's like an empty box to be filled right here. So what number minus 6 do you think gives you 3? If you're thinking 9, that is correct, right? So you're thinking this. But the questions will be given to you in terms of x minus 6 is 3. So you're thinking x is what minus 6 is 3. And you're thinking that's 9. And then you go, okay, then we say x is equal to 9. Okay. Let me use a different color. X therefore is equal to 9. Now, when you do example B, same thing, guys. When you see X, you're literally thinking a box to be filled plus 3 is 7. So what's the box? And the box is the X, and that is 4. Like this. Okay, so you're just thinking this right here, guys. Okay, now we're solving one variable this time using the property of equality, right? So what that means is that you could do onto one side, and whatever you do to the left side, you do to the right side. Okay. The goal in this case is to isolate the variable x. That's what we're looking for, solving for the unknown. So you're looking for the inverse of -6, which is what? +6 both sides, which means that will cancel to 0. So x is equal to 9. Well, by the way, I'm going to put this in a thought cloud right there. You should think that. If you want to write it down and that makes you comfortable, great. But it is not necessary. Okay. If you put it there, perfectly fine. If you opt not to put it down but just think it, I'm okay with that as well. And then example B, what do you think? And please feel comfortable in pausing the video so you can answer the question first, okay? I'm going to assume that you do that as you watch the video. For example B, what do we do? Yeah, exactly, we subtract 3 from both sides, right? Remember, we're using the property of equality here. So when you subtract 3 from both sides like this, that 3's cancel. So x right there is 7 minus 3 is 4. Okie dokie. All right, guys. So I went over that in period 2, in basically the same thing, and then period 4 as well. Okay, if you missed a note, you could copy either one of those two versions. All right, let's go with this problem. So we're talking about the property of equality in terms of words, numbers, and algebra. Okay. In the addition property of equality, you can add same numbers to both sides of an equation, and the statement will be true. The way to sort of think about that is, let's say you have a seesaw like this, right? And there are two people sitting there. Well, to keep it balanced, if you add the same amount of weight to either side, it will stay balanced, right? You can subtract the same amount from both sides, it will stay balanced. If you double the weight to both sides, it will stay balanced. And if you halved both sides, if you could magically do that, it will still stay balanced, right? That's the underlying idea behind it. So with the addition property says you could add the same number to both sides. Subtraction property says you could subtract the same number from both sides. Same thing with multiplication, where you could multiply to both sides, right? And you could divide to both sides, except has to be non-zero. You can't divide by 0, right? At least not yet. Here in the multiplication, you can multiply by 0 to both sides, but that makes the problem very uninteresting. Okay, so instead of me writing this out one step at a time, let me just show you. Okay. All right, guys. So for example, the very first one is, let's say you had 3 is equal to 3. What that means is that you could add 2 to both sides like this, and you'll end up with 5 equal to 5. Check. Right? What if you had A is equal to B and you add C to both sides? When you add that, we end up with A plus C will be B plus C. Okay, so this is a little more like it isn't algebra or just an expression, right? And same thing goes with subtraction. If 7 is equal to 7, you can subtract, let's say, for example, 2 to both sides. You'll end up with 5 equal to 5. Check. That's absolutely correct. And then if you have A equal to B, whatever that may be, right, you're allowed to subtract the same amount. So A minus C, therefore, is equal to B minus C, as long as we know that the A is equal to B. That's the premise here, guys. Okay? It doesn't have to be non-zero, but generally. So this is generally non-zero. Okay? Almost all of the time that we do it, it will be non-zero. So let's say you have a number 4 is equal to 4, guys. And then let's say you multiply 2 to both sides. And you can see that they're both 8. So that's just one small example that might be true. So if you had A is equal to B, according to this property, multiplication property of equality, you could multiply K to both sides. And this relationship, Ka and Kb, will always also be equal to each other. And finally, division property equality. Let's say you got 4 to equal to sides, and let's say you decide to divide by 2 to both sides. You will end up with 2 on both sides. So if A is equal to B, and you divide by K to both sides, then A divided by K has to equal to B over K as well. Note that K cannot be 0. Hence, you could divide by non-zero numbers. Okie dokie, guys. And why don't you go ahead and try these two problems and just pause the video. Okay, I'm going to assume that you have already done it, and here are the answers, guys. Let me zoom in a little bit. So you add 1 to both sides, and if you do that, you get 2x equal to 7. And then to get rid of the 2, we divide by 2 to both sides here. And then you end up with 7 over 2. Another way to sort of think about this is 2x minus 1 equal to 6, guys. You could think of 2x as, hey, what minus 1 equal to 6? Whatever that is must be 7, right? So that's what we did. So 2x must be 7. 2 times what must be 7? 7 over 2. You could do that, but I think at this point, it's probably better to use a property of equality, which basically means what? You could either add both sides same amount, you could subtract the same amount to both sides, multiply the same amount to both sides, and you could divide by the same amount to both sides, except 0. And for example, 1b, I'm sorry, before we go there, whatever the answer we have, guys, we pop right back into x to check if it's correct. So let's get the left hand side, shall we? 2 times 7 over 2 yields 7. 7 minus 1 is 6. Check. All right, guys. For 1b, to solve and isolate the x, solving for unknown means that you have to isolate the unknown. In this case, it's the x, right? First thing we do is subtract 2 to both sides. So 1/2 x equal to 2. To rid ourselves of 1/2, we do the reciprocal of 1/2 multiplication, which is 2 on both sides, and that yields 2. Once you're done, you need to plug this in back into the original equation, which I did over here, to make sure that the left is equal to the right. Okie dokie. All right. So this is a quick recap of what we did today. Example, period 4, something, same thing. All right, guys. Why don't you guys go ahead and try to do this the best you can, if you can. But you need to follow this procedure. After you read this over here, guys, let statement where you declare the variable. So we need to have a let statement. And then we're using the let statement and with given information, set up the equation. Once you set it up, solve. And then whatever thing that you find, do the conclusion. In the old textbooks, they call this a 5-step process. But if you're thinking 1, 2, 3, 4, Mr. Yim, there's only 4. Well, that is because you should check your work afterwards, right? It's a 5-step process. Why don't you go ahead and try these two problems and see what you could do with it. Okay. Now, let's examine this question a little bit closer, okay? So in 1963, Martin Luther King began his famous speech, I Have a Dream, with the words, here comes, 5 scores ago, a great American in whose symbolic shadow we stand, signed Emancipation Proclamation. And that Proclamation was signed by President Abraham Lincoln back in 1963. So how long is a score? Right. When you read that, it's like, what is a score? So there are 5 scores, right? Okay, that's what we're looking for. Because the word score begins with the letter S, so let's just use that. S is score, value. What is the numerical value of a score? Is it 20,000 years? Is it 2,000 years? Is it 2 years? 5 years? 10 years? I don't know. Because we know that decade is 10 year, right? Century is 100 years. So what is a score? All right. So it appears that in 1963, it started. That's where it started, right? And then we added, how much time has elapsed, guys? 5 score years ago. There are 5 scores, 5 S's has elapsed. And then it became 1963. Just like that. Right? So that's the setup. Now we're going to solve. And we're going to conclude them. Do me a favor, guys. Go ahead and solve that. Now what I'm going to do is look at question B. So an airplane descends in altitude from 20,000 to 10,000 feet. As soon as I read that, in my mind, I'm thinking, okay, there's a 20,000 feet, and he went down 10,000 feet like this, guys. Okay? A gauge in radar traffic control reads the airplane altitude dropped from here to here was 1.8939 miles. How many feet are in a mile? Okay. How do I do this? So we know that this went down how much, guys? It's not 10,000 feet. How'd you get that, Mr. Yu? Well, according to this, let's say we don't know that yet, right? What it said was 20,000 feet minus 10,000 feet is equal to 1.8939 miles, right? It's asking how many feet are in a mile. When you say a mile, it is a 1 mile. So I need to make sure that this number is equal to 1 mile, right? So this is one way to set it up. And next page, I'll show you a slightly different way to set it up. So on the left-hand side, that's equal to 10,000 feet, and that's 1.8939 miles, like this, right? You solve for the mile. So you divide both sides by 1.8939 miles, right? So 1 mile is equal to 10,000 feet divided by 1.8939. And then why don't you go ahead and finish to see what the conclusion is. Okay? All right, guys. I'll show you what we did in class. So we did basically the same thing, right? Yeah. S is a score. And then we went ahead and after we set it up, we solved for it. Subtract 1863 from both sides, which gives you 100 on the right-hand side. After we divide by 5 to both sides, we get 20. So each score is 20 years long. So decade is 10 years. Score is 20 years. And century is 100 years. So I did the same exact way over here, guy. Didn't I? So 20,000 to 10,000 feet. That's equal to 1.8939 miles. And I wrote it a little bit differently. In that 1.89 miles, and I'm going to call M the rate that tells you the number of feet in a mile. So when you multiply it, you should get the feet on the right-hand side, right? So when you do that and you divide by it, you're left with the 1 mile here. 1 m is 1 mile. and you get the same expression we had before, and put it in the calculator to the nearest foot. Turns out to be 5,280. The reason why I put a squiggly equal sign is that it is approximately, because I didn't copy down every decimal value from your calculator. I rounded it to the nearest foot. So each mile, therefore, is 5,280 feet. Okie dokie. All right, guys. So let's move on to the next question for you to practice. So there are, what is it? 4 questions. And in your notes, I probably deleted these 2. And then you might want to copy that's 108 inches. And then what else? Taller than 4 times the height of kiwi. And then you might want to copy 70 inches less than 5 times. Okay, those are the missing values. And once you go ahead and try this problem, why don't you pause the video first? Okay, I'm back. And the answers are as follows. Okay. That concludes what we did in class. So thank you. And then if you have any questions, be sure to come to the tutorial, and I'll see you in class.